Alright, welcome back to the section on the mole. We are going to do in this video as many example problems as we can. So I'm going to go somewhat quickly. So if you have questions or need to, you can always pause the video and go back. But I want to try to get through as many as I possibly can. So for this first one, how many aluminum atoms are there in 13.57 grams of aluminum? So basically, I'm starting with a grams, and I'm asked to go to how many aluminum atoms there are. So I'd go right here. So I need to do two conversions. I need to first go from grams to moles, and then I need to go from moles to particles. So let's set that up. Essentially, this is a dimensional analysis problem. So 13.57 grams, and I'm looking at aluminum. Always write the substance so you know what you're in. So 13.57 grams of aluminum. First thing I want to do is I want to convert from grams to moles, and I'm going to do that using my molar mass. Grams of aluminum will go on the bottom. Moles of aluminum go on top. And so remember, grams per mole, that's molar mass. So 1 mole of aluminum, what would be the mass of that? Well, since it's just aluminum, I just have to look at the periodic table, and I see that it's 26.98. All right? So by doing that, that's going to cancel out my grams. And then my next step is I would want to convert from moles of aluminum to, what is aluminum? Is it a particle? Is it a molecule? Is it an atom? It's an atom, right? So I'm not giving myself much space. Atoms of aluminum. And so 1 mole of anything is going to be 6.022 times 10 to the 23rd of that thing. And we already said aluminum is an atom. So that's going to make my moles cancel. And that is my final answer. That's what I want. I want moles, or I want atoms of aluminum. So now I'm going to do 13.57 times 6.022 E23, and then divided by 26.98. As far as significant figures go, 4 significant figures is what I'm given. So my answer is going to have 4. And so that's going to be 3.029 times 10. Make sure it's times 10, not E. Atoms of aluminum. That would be my answer there. Let's take a look at the second question. How many aluminum atoms are there in 17.22 grams of aluminum oxide? This one sounds very similar. I'm starting off with the grams, just like I did last time. But this time I'm going to a particle within a particle. So you see how it gives me the mass of a compound? But I don't want to know how many molecules of that compound. I just want to know how many aluminum atoms there are. So that's why once you get to the particle, which would be, in this case, the molecule, we need to actually go one more step and go atoms in a particle. So anytime you're asked to solve for the quantity of a particle within a larger particle, you would want to do that extra step. Let me show you what that looks like. So starting out with 17.22 grams of aluminum oxide, and I tell you it's Al2O3. First thing we need to do, we need to go from grams of aluminum oxide to moles of aluminum oxide. Remember, moles are central unit. The mole, once you're in the mole, you can get anywhere. So 1 mole of aluminum oxide will weigh how much? Well, this is where we need to do the molar mass. So let's figure out what that would weigh. 26.98 is the mass of aluminum times 2, plus 16 is the mass of oxygen, but times 3. Looks like the molar mass is 101.96. So that's my molar mass. And so by doing that, that's going to make my grams cancel. Now my next step is I need to go from moles to particles. So 1 mole of aluminum oxide will contain 6.022 times 10 to the 23rd. Now be careful here. What is aluminum oxide? It's a molecule, right? Well, technically it's a formula unit, but we'll call it a molecule. So 1 mole of aluminum oxide will contain 6.022 times 10 to the 23rd of that molecule. So it's molecules of Al2O3. So this is why it's important to make sure you keep track of what substance you're in. Because right here, students would mistakenly think that they're done. They would think, oh, well, I converted to a particle, I'm done. But the particle that we converted to is molecules. But the question is asking not about how many molecules, it wants to know specifically how many aluminum atoms. So we need to go one more step. We need to say, okay, I'm in molecules of Al2O3. Well, if I had exactly one molecule of Al2O3, just one, how many aluminum atoms would that contain? Well, take a look at the formula, Al2O3. One molecule of Al2O3 contains 2 atoms. So there would be 2 aluminum atoms for every one molecule. So that's where we do that last step there. And you can see that is actually how we set it up right there. These conversions are what we're using in the problems. So number of atoms in one particular particle of what you're looking at. So now we're in the right unit of what we want to be, aluminum atoms. So let's calculate. 17.22 times 6.022 E23 times 2, and then divided by 101.96. My significant figures are based off of this number here, which is 4. So my answer is going to be 2.034 times 10 to the 23rd aluminum atoms. All right. So let's look at some more practice. All right, this first question here. And I encourage you, if you think you know how to do these problems or want to try some on your own, pause the video and then you can hit play to look through the answers. Okay, how many moles of carbon dioxide are there in 3.75 grams of carbon dioxide? This one's a little bit more straightforward. We're just asked to go from 3.75 grams of CO2, and we want to go to moles of CO2. So to do that, grams of CO2 go on the bottom, moles of CO2 go on the top. And what's going to relate those two? Molar mass. 1 mole of CO2, let's see what that is. 12.01 is the mass of carbon, plus 2 oxygens is 32. And so total, my molar mass is 44.01 grams. So my grams will cancel out. And then I'm done. I don't have to go any further because it just wants to know moles. That's it. So I can stop right there. 3.75 divided by 44.01, keeping 3 significant figures. Remember that the zeros that begin the number don't count. So here's where my significant figures start counting. 8, 5, 2. And that's moles of CO2. In the second problem, we're going the other way. How many grams are there in 9.86 moles? So we have 9.86 moles. And what are we looking at? We're looking at gold, which is AU. This time I'm going the opposite direction. I want to go from moles of gold to grams of gold. Once again, this is going to be our molar mass. 1 mole of gold, let's take a look. It's element 79. That's 196.97. This will make my moles cancel. And so let's figure out what that would be. 9.86 times 196.97. Keeping 3 significant figures. My answer, I get an answer that's 1,942. I'm going to put that in scientific notation because it's such a large number. And that'll help me with my sig figs. So I'm going to make that 1.94 times 10 to the 3rd grams of gold. All right, looking at number 3. What is the mass, so we're going to solve for grams, of 2.23 times 10 to the 24th formula units of potassium phosphate? So now we're going from particles to mass. We have to go through the mole first, so we're going to have a couple conversions here. Remember, for formula units, think of it as molecules. And potassium phosphate, I forgot to add into the slide that it's K3PO4, because at this point, you don't know how to write chemical formulas just yet. So we need to know what that is. All right, so I'm going to start out with my number, 2.23 times 10 to the 24th. And it's formula units, technically. It's not real, there's not really an abbreviation for that, but it's K3PO4. Okay. First thing I want to do, since it's a particle, let me go back real quick. So we're starting here, particles. We need to go back the other direction to ultimately get to grams. So we're doing the same work that we did before here, but we're just going in the opposite direction. So to cancel out formula units, which is a particle, I'm going to put that particle down here. Okay, formula. I'm just going to put 4 units. And then moles goes on top here. Remember, 1 mole of anything. And let me write this a little bit better so I give myself some more space. Okay, 1 mole of anything, in this case it's 1 mole of K3PO4, is going to be equal to 6.022 times 10 to the 23rd of that particular thing. The reason it's a formula unit specifically is because this is an ionic compound. But just think of it as molecules if it helps you think about it that way. There's that many molecules in 1 mole. And then our last step is I want to go from 1 mole of K3PO4 to grams of K3PO4. And this is where I had to give you the formula because we need to figure out what the molar mass is. So let's figure out what that's going to be. Potassium is 39.1, which is K. There are 3 of those atoms. Plus, the mass of 1 phosphorus is about 30.97. Plus, the mass of 4 oxygens is 64. So altogether, this compound has a molar mass of 212.27. And I can't stress enough, you need to get practice with calculating molar masses quickly because you'll have to do them pretty quickly for assessments. The formula units cancel, the moles cancel, and we are in grams. All right, so what do we get? 2.23 times 10 to the 24th times the molar mass 212.27, and then divided by 6.022 times 10 to the 23rd. With 3 sig figs as for my answer is going to be 786. So there's 786 grams of the potassium phosphate, K3PO4. All right, let's try to get one more in this video, and we'll finish up the remainder in the next video. How many oxygen atoms are there in 5.78 grams of magnesium acetate? And I just remembered I did not give you the formula for magnesium acetate, so I have to. And it's a big one. Yeah, right? That's pretty crazy, huh? No worries, it's not that big of a deal, and you'll get really good at that in a later topic. But we need to know that so we can figure out the molar mass. So we have 5.78 grams. First thing I want to do is I want to convert from grams to moles, because then once I'm in moles, I can then get to particles. So 5.78 grams, we are looking specifically at magnesium acetate. Okay, and we have Mg. I need to get better at writing the whole thing out. And there's a reason why I do that. Even though it's a pain in the butt, I know. Okay, so 1 mole, how much does that whole thing weigh? Well, here's how you figure it out. Magnesium, there's only 1 magnesium. This 2 right here corresponds to all of the atoms inside. So there's double the carbon, double the hydrogen, double the oxygen. But the magnesium, there's just 1. So that is 24.31 plus, how many carbons are there? There's actually 4, right? So I'm going to do 12.01 times 4 plus, how many hydrogens? There are 6 hydrogens, so 1.01 times 6. And then plus there are 4 oxygens, so 4 times 16. So total, the molar mass is 142.41. That'll make the grams cancel there. Oop, not the magnesium, the grams. All right, so then the next thing is now I can go from moles to particles. So 1 mole of magnesium acetate, C2H3O2, will have 6.022 times 10 to the 23rd. But here's the thing. We're in magnesium acetate. That's a molecule. Technically, it's a formula unit, but I'm going to call it a molecule. All right, so are we done? We're not, because it's not asking how many molecules of magnesium acetate. It wants to know specifically just oxygen atoms. So this is where we do our final step. If we had just 1 molecule of the magnesium acetate, C2H3O2, and I'm getting really sloppy. How many oxygen atoms are there? Well, if we take a look at the formula, there'd be 4. So that means my final answer, when I calculate everything, would be 9.78 times 10 to the 22nd oxygen atoms. Real quickly, I just noticed I forgot the 2 there.